Welcome to the second video of the lecture series on the structures and properties of matter. On this one, we're going to be talking about the difference between physical and chemical properties of matter. And we're going to talk about how we can use them to differentiate between substances. Every substance has a unique set of properties, whether it's a compound or an element or even a mixture. Every substance is unique in the way it acts physically and chemically. Now, do remember that mixtures are not chemical substances. They're physical substances. They're combined in the same space, but they're not actually chemically bonded or combined by the sharing of electrons, right? That would be a compound. So within a mixture, it's as if you have individual chemicals, each with its own properties, all in the same space, which is different from what you would have in a compound, which is elements or chemicals combined together to create a new chemical unit with its own unique chemical characteristics. Now, whether you're talking about any of those, physical and chemical properties can be useful in helping differentiate between them. A chemical property is a property that refers to its substance as it relates or interacts with other substances chemically. And physical properties have to do more with the substance by itself. It's a characteristic of the material itself, without necessarily needing to relate with other substances chemically. There is one little one that confuses me with this definition, but that's why I said the word chemically at the end of that definition to try to set the difference apart. And we'll talk about that in a second, which is the idea of solubility. But here's some examples of chemical properties. The toxicity of something, the oxidation state, the heat of combustion, the chemical stability, the flammability, reactivity, what it can bond to, entropy of formation. All of those concepts only make sense in the context of a chemical reacting to another chemical. And that's why it's a chemical property. While a physical property, such as color, shape, mass, volume, texture, if it's magnetic or not, the length of it, the state of matter it's in, and several others we're going to talk about in the next set of videos, are all going to be examples of physical properties because you don't need another chemical to react to your chemical in order for you to know about those properties. So you can investigate those properties without another chemical reacting to it, then it's a physical property. But if you need another chemical to react to it in order to investigate those properties, then it's a chemical property. So I think of it as a chemical properties is how it relates to other chemicals, and then physical property is how it defines itself without the need of other chemicals. All right, so we're going to go over a few now of the next few slides. So here's density. So density is this idea of how much mass can fit in a certain amount of space. And again, you can talk about that without the need of another chemical. So that's definitely a physical property. Having said that, you can use density in mixtures where the chemicals separate by density to help you differentiate between the layers of that and therefore separate the different chemicals within a mixture. So you must have seen pictures like the one on the top right here where you can create these layers by density. The denser material will tend to sink to the bottom of a heterogeneous mixture, right? But that doesn't mean that it's interacting with the other chemical per se. It's just interacting differently with the gravitational field of the Earth, calling it to be pulled down to the bottom more than the other one is. So it's not reacting chemically with the other chemicals in the mixture. So it's still considered to be a physical property, right? It also, you can define it by itself. You don't need another chemical to compare its density to. You can actually measure its volume, you can measure its mass, and then use that to calculate its density. Likewise, the idea of state of matter, it's something else that you can examine without the need of another chemical. Whether it's a solid, a liquid, a gas, or plasma, that has to do with how much the particles are moving and the attractions between them, which, by the way, we're going to talk about in the third objective of this series. That's all it's all about. Basically, that's not necessarily a chemical property because it doesn't have to relate to another chemical reacting to it. pH, or how acidic something is, or how alkaline something is a chemical property because that has to do with how it reacts to corrode or steal electrons or interact with other chemicals in particular ways that you learn more in high school chemistry. But it's a chemical property because it has to do with reacting with another chemical. If you look at the idea of electronegativity, again, it's a tendency of an atom to steal electrons from another. That's going to be chemical because it's the idea of reacting to another atom and stealing from it. The melting point. Can you talk about that without the need of another chemical reacting to it? Absolutely. That just has to do with the temperature at which the state changes between solid and liquid. So it's going to be a physical property. And last but not least, we have the idea of boiling point. And again, that has to do with the temperature in which the liquid changes between liquid and gas, or the material changes between liquid and gas. And again, a physical property, because you don't need to relate it. So I hope you're getting the gist of this. Now, you don't need to know all these properties by heart, these definitions, but you do need to know how to recognize if they're physical or chemical. And again, the secret is to ask yourself each time, do you need another chemical reacting to it in order to examine that property? So the ability to rust, right? So that's a metal's tendency to become oxidized or combined with oxygen. So that sounds like what? It sounds like it's reacting, right? So it's going to be a chemical property. And reactivity, again, kind of in the name, the chemical tendency to react with others, obviously a chemical property. Flammability, the chemical's tendency to burn, which is to react explosively with oxygen to form water and carbon dioxide. So that means obviously a chemical property, right? Odor, it's a physical property because you do not need another chemical for that chemical to have its own smell, right? So in other words, the substance's smell has to do with its own physical characteristics. Likewise, color. It's basically just what wavelength of light the material tends to reflect. So that too is going to be a physical property. If I feel on left here, opacity is whether or not you can see through it. It has nothing to do with reacting, physical property. Viscosity has to do with how resistant the material it is to flow. Like honey is very viscous, more than olive oil, and even more, which is less than water. Right? Water has the least. So olive oil, water, and honey. Water would be less viscous than olive oil and then honey, right? So it's that substance resistance to flow. It has nothing to do with reacting to something else. It's just its own resistance to flow. So it's going to be physical property. Solubility. I said I was going to have to talk to you about that one. So that one is tricky because it's the substance's ability to dissolve in another substance. So that gets tricky with a definition that you only need one substance to examine those characteristics, right? So, and it also gets tricky because a lot of people think of solutions as a chemical reaction versus a physical reaction, but it depends. Some solutions, like when you put sugar in water, the water just surrounds the molecules of sugar and dissolves it without breaking it apart. While other ones, like when you put salt in water, the water actually separates the parts of the salt and surrounds when it surrounds it. And in a way, that would be considered chemically separating the atoms. So solutions are a little tricky, all right? Is it a chemical reaction or not? In general, it depends on the circumstance, but with salts, most people would consider it a chemical reaction. With things like molecules, organic, which are not ionic, right? You're talking about covalent bonded molecules put in water. That would be more so a physical solution. Regardless, for the purpose of this topic, if you're not talking about the solutes reacting to the water, just mixing with the water. Now, remember, we talked about how a mixture is a physical combination of materials. They're not chemically actually combining, they're physically combining. So if you're talking about a solution in those terms, then you're talking about, in other words, can it form a mixture with water in a way that you can't see what's inside very well or not? That is more a physical characteristic than a chemical one, right? It's ability to mix with water. And since mixtures are a physical thing for the most part, then I would consider it a physical property. So that's a tricky one, but I just wanted to have a little action on this video, so that's why I included that one. But about things like size, which is how much space it takes up, or mass, which is basically the amount of stuff that it has, which is, by the way, different from weight, which is the object's interaction with the gravitational field of another object, right? Either one of those, though, would be a physical property because it doesn't need another chemical to react to it. So don't get too caught up on the definitions of each specific property that was mentioned in this video. The idea of going through them was just to give you examples of whether or not it was physical or chemical, depending on whether or not it's talking about one thing reacting to another chemical. And that hopefully will help you prepare to any kind of question you deal with time like these. The ones you're going to see to test the most are going to be things like rusting or burning. Those are the ones that have to do with chemical reactions taking place, right? Or acids interacting with and corroding something else. The last point to discuss in this topic is how you can use those properties to differentiate between things. Because the thing is, every substance has its own set of unique physical and chemical characteristics. And so you can use these characteristics to tell them apart, because every substance, the total combination of physical and chemical properties of the substance is unique, whether it's an element or compound. Now, there are two specific ones that the test talks about, which help us. First of all, remember that during a chemical reaction, what's actually happening is that bonds are being broken and formed. So if you have bonds being broken, then you actually have a chemical reaction, which is why I said that you would put salt in water and you dissolve that. It's technically a chemical reaction because it does break the bonds within the salt molecule. So that's when it gets tricky about whether solubility is a physical characteristic or not. It depends on the type of solution, right? But in general, the questions you're going to see in the test that talk about chemical reactions, they're talking about situations where you have new sets of chemicals forming. So every time you have a chemical reaction, you're going to have a new chemical with a new set of chemical and physical characteristics. So if you have a chemical reaction or a chemical change, that's what you're going to be seeing. Then how can you use that to differentiate between things? So two specific ones that are mentioned in this assessment is the idea of density and the idea of melting and boiling point. So you can use density to separate substance in a liquid, because with something that is denser, we have a tighter tendency to sink to the bottom of the liquid if it doesn't mix very well with it. So if you have a mixture that's heterogeneous, when you can actually see the parts, the denser parts would tend to sink to the bottom, and you can use that to differentiate between the parts of the that are inside. The other part about boiling point is that while you can't trust things like color, things like size, things like temperature to know if something is a mixture or a pure substance, you can use things like the melting point or the boiling point of the substance. Because if a substance is pure, its melting point is going to be exactly what it is for that substance. For example, when you try to boil water at a atmospheric pressure, it will boil at exactly 100 degrees Celsius. If you try to freeze water or melt water, it will happen exactly at 0 degrees Celsius at atmospheric pressure, sea level. So that means that if you try to boil water at sea level and it doesn't boil at that temperature, it's not water. It's got something else inside mixed with it, which is altering the properties of that, and therefore it's a mixture or not water. And so, how can you tell if something is a mixture or not when it's not something that's having difficulty mixing, where you can just use the density? Well, you can try to boil it, and if it boils at the temperature that you expect, then you know it's pure. If it doesn't, then you know there's other things mixed inside. So I hope that you found this helpful. On the next video, we're going to talk about objective 3, which is focusing on the behavior of substances as they gain or lose energy in the form of heat. I'll see you guys then.